Hey everyone, this is episode 1 of Wizard Gear Games. So today we're going to be working on a little bit of a project here in Unity 3D. We're going to be laying out the basic architecture for basically a wargame battle simulator. It's going to basically draw on the 8th edition 40k rules for Warhammer 40k. And yeah, we're just going to lay out the basic architecture today. So we have here our basic Unity project. We've got the setting up some namespaces here. I've already set up a few empty directories. Core, we're going to spend a lot of time in the core directory. And we're also going to be namespacing all of our classes. Yeah. So let's go here and we'll just get the base controller. We'll lay that out. So basically in our core namespace, we're going to basically use the topmost ancestor of everything else, right? So base controllers, base rules, basically everything that can be inherited. We're going to put them in the core here. And we're going to have all of these be game scripts that inherit directly from mono behavior, which is in the Unity engine namespace. And the reason we're doing this is we want to have sort of a onion type of architecture. We want our architecture to be in layers, right? I've noticed in the game development world, not a lot of attention is paid to code architecture, at least from beginners. At the pro level, it's a major concern. But by setting up a good architecture from the beginning, we can set ourselves up for success later on. I'm using OBS to capture the screen here, and it's a little bit slow. I'm really pushing my MacBook to the limits here. I've only got about 16 gigs of RAM, and that's not nearly enough to do screen capture and a high-level game development inside of Unity. So what we're going to do is we'll basically just have, we're going to spend a little bit of time in Unity Editor, and then we're going to hop over to Mono Develop for most of this video. Yeah, we're going to have our controllers, our data sheets, basic engines. We'll fix that typo in a little bit. But yeah, we're just basically laying out the core kind of components that we're going to have in our system here. The idea is that this code should be highly portable. At least a lot of the core logic should be portable enough that we can use it across multiple devices. Whether we want to actually use it in a game or some kind of army list type of application, like army list builder application, we can do that too. You know, we'll be able to build iOS or Android or even desktop games with this. Now we're switching over to Mono Develop. And just taking a look at the solution file. I'm just kind of curious to see how Mono Develop is going to set it up. But you don't have to worry about that. I have a big .NET background, so I'm just kind of curious. But now we're going to namespace our classes. I think this is fairly important. I don't think a lot of people in the community are doing this enough. Namespaces are very important. You know, you don't want to shove everything into the top level namespace. It doesn't make sense. Especially if you're going to take your code and package it up as an asset for the asset store. You really don't want the potential of your code colliding a namespace with somebody else's code, you know? If you want your code to be reusable, you should be a good citizen, a good packaged citizen. Everything should be nice and tidy. So here we are, we're going to fix the typo in our base data sheets. Base data sheet class here. And we're also going to have to change the name of the class here too. But, you know, we're just typing it all out and formatting it correctly. There we go. I got the base engine here. And those of you new to Unity development, you'll see the void functions called start and update. These are used internally by the Unity engine during game object, during the game loop, at various points in the game loop to update the state and behavior of game objects that may be instantiated in the scene. And you can't see the menu on the screen, but basically I'm just selecting all this and going up at the appropriate menu up in monodevelop to format my code. I'm kind of a stickler about having my code formatted properly. It's a big deal. Now this base rule class. Future, the actual rules, the actual objects that we instantiate to implement the various rules of the system will all inherit from this particular class here. Sorry about that. I'll try to clean up any of the pops and hisses, but I don't have my pop screen with me today, and I'm not using my condenser mic, so this may be a bit messy on the audio side, but I really want to get this video out for you guys. And of course, we can have some special rules, and those special rules, they should inherit directly from the base rule. See a little typo there? It was very late when I recorded the video, when I did all the screen capture for the video. So. Any of the war gear or any of the other equipment that our models can be equipped with, of course, will all inherit from our base war gear class. And you know, maybe in the future we'll go back and we'll change the access level of some of these classes. But for now, we're just going to leave things as public classes and public enums, or public enumerated types. That'll be fine for now. I got a little bit of a typo there. There we go. So now we're going to make an enumeration of all the different factions that we're going to have in the game here. And of course, some of these names are the copyrighted intellectual property of Games Workshop. But this isn't commercial software, this is free open source software. And we're not going to be actually distributing any of the real Games Workshop rules. So, my understanding of the use of their copyrights is that you can talk about the game, you can talk about the factions, you can talk about a lot of things in the Games Workshop universe, but you can't distribute any of the rules or the data sheets outside of what they may have made publicly available. So we're basing this entire project on the free rules for 8th edition that they've released, with the Battle Primer, or whatever it is that they're calling it. There's a PDF on GamesWorkshop.com. Now the controller is going to be interesting. Basically, it's going to do just what it says. It's going to control various aspects of our system here. Using a controller is kind of a holdover from the web development days, but even more importantly from the MVC paradigm, right? Only in this case, our models aren't going to actually be data access. Models are going to be tabletop models. But similar enough to where maybe a bit of a light MVC or model view controller pattern is a good basis to start with for our architecture here. You'll see that I'm adding comments to all of my classes here. Get in the habit of commenting your code right away. You know, you want to comments at the class level should be why the class exists, not how it exists, right? The implementation details should be in the code itself. At the class level, you just want some high-level documentation just as a purpose of the particular class. All right, let's take a look at our factions enumeration again here. go look up a few different factions. And the faction list is so huge at 40K, so I may have missed some. If I have, go ahead and leave some comments, let me know. I'm not a lawyer. That may be unacceptable or unacceptable legalese, but it'll work for the purposes of this video. And I just copy and paste this list in from another file I had open. All right, now we're going to make another enumeration here for our turn phases. And basically, we're going to be using the switch statement later on in the engine to switch over the enumeration, figure out which turn it is, and if certain actions can occur during certain turns. We're going to use as little reflection as we can get away with. Don't be quick to grab reflection as a go-to technique during your development. It is costly. It can be very costly, especially if you do it too much, or if you do it in inappropriate times. So, simply tagging things with the enumerated type of the turn phase is to when that particular object can act. It'll be a little bit clearer in terms of understanding the code, but it'll also provide us a performance optimization out of the gate. Of course, you want to be wary of premature optimization, but we're just setting ourselves up for success here. And now we're going to make some fields. In the Unity editor, public fields are visible in the editor, can be edited directly from the editor. If they're private, they can't be unless you turn on debug mode in the editor. So we're going to have a 2D portrait as a sprite. We'll make a game object type for the 3D portrait. For now, we're going to assume that a model can belong to one faction. Now, that's not technically true, depending on how you interpret the rules of the system, but we want to make a prototype today. We don't want to worry about the minutiae later. We can always refactor and change things around later if we need to expand on our architecture. So we're going to have a list of friendly factions and a list of enemy factions. You could probably use an IEnumerable here, but I like lists, and also lists are easy to update and edit inside the editor. So we're going to check if the game is running a debug build, the engine is a debug build. If it is, we're going to output some useful information to the debug console. So basically, this .get type is basically, you can look at it, even though it's not like a reflection namespace, you can look at it as a reflection. We're asking this particular instance of a base model, what your type is, what your name is. And we want to know the declaring type. But of course, this log statement's only going to occur if we're running a debug build. There's a lot of different things we can do here. But for now, we're not really sure what initial state we want the model to be in when it starts. So we'll just leave this more or less like this for now. We may come back to it later. We'll certainly come back to it later once we know more about the system and see how it evolves. But for now, a little bit of a debug statement works just fine. All right. So we're going to start working on some more of our namespaces here. We're going to want a separate namespace for the turn phases. So now you can see we're going to be opening up and using that namespace, that core namespace that we created before. This is a typo. Again, it was very late. I'm actually trying to set the namespace here. But I'm wondering why it's not working. I'll fix it here in a moment. Oh yeah, there we go. We caught the error. Now the goal here is we're going to make a class for each phase of the turn, right? And we're going to be able to have. Eventually, we're going to want to have a collection of models that are active in that particular phase. We're actually going to need two collections: the active player's turn and the opponent's collection of models. We're going to want references to these so that we can act upon them and implement our game logic. Again, this may seem a bit redundant, but we're going to tag this with a static read-only member that pulls from that enumeration that tells us which phase this is. In practice, we don't want to be asking objects, especially during runtime of the game, information about themselves by a reflection at all. We want to be a little more efficient than that. Again, it's not necessarily premature optimization. It's just, I mean, it is kind of maybe a premature optimization a little bit, but I find that that actually adds to the clarity of the overall architecture of the system. And again, this is really quick. We're just we're changing the class name and the member on turn phase from that particular enumeration. Morale phase is a bit tough. Well, not from the logic perspective, but from a player's perspective. You know anything about Warhammer 40K? Basically, in the morale phase, if some of your guys in the unit have died, they have to pass a leadership check, a morale check, to prevent further models from fleeing. And we're creating these classes out of order with the actual sequences in the tabletop game, but that's fine. Now what we need to do here in a future episode is make a base phase class to inherit. All these phases should inherit from a base phase, because we don't want to have the same logic over and over and over. outside of this particular static tag here, this static member. There's going to be some bookkeeping that's going to be common to every phase, and we're going to want to put that into a base class so that we don't have to, well, repeat ourselves. But also it'll allow us to do things like accept the base class's input, and then any class that inherits from it should be able to be acted upon with the same logic. Now, if we need further separation of concerns, we can always break out some interfaces. We can extract the interfaces from these classes, and you know, at some point, though, you don't want to be, you know, at some point in time, components have to be coupled together, right? You don't want to be over-eager in decoupling all of your components, you know. Just decouple them when it makes sense. Otherwise, you know, I used to run into a problem where I'd be almost dogmatic about my decoupling of my components with each other. And it's not the wisest move, you know. So now here we're adding some public fields that represent the various characteristics on the data sheet or on the model profile for each of the models. Movement is, you know, how far they can move each turn, usually expressed in inches. Weapon skill determines their strength with a type of like melee weapons. Ballistic skills, of course, their ability with shooting weapons. Strength, you know, that plays into calculations with whether or not they're successful in using their melee attacks. Toughness is how strong the model is. Wounds is how many hits the model can take before it's destroyed or killed or wiped out. Attacks is how many attacks it has, how many melee attacks it has during the fighting phase. Leadership plays a role in determining whether or not this model is going to have a hard time passing morale tests. And the save determines whether or not the model is going to be hit. So this should all be pretty familiar to you if you have any experience playing Warhammer 40K on the tabletop. And so we're going to add a Boolean here. Has invulnerable save. This is a type of save that some models have. Basically, an invulnerable save does not take into account armor piercing or armor penetration, if I remember correctly. I'm still a bit new to 40K, but I really like the game a lot. Now, of course, we can refactor this, right? You might say, well, we could have invulnerable save set to 0, and we could, you know, check an invulnerable save at 0 to be false, but that's kind of muddy, you know, that's not really clear. You know, but we can do some business logic, right? So if it doesn't have an invulnerable save, and we try to modify or use the value of the invulnerable save, we can put some checks in our logic. Alright, so there's different types of units in Warhammer. We have headquarters units, we have troops, we have elites, we have fast attacks, we have area support. We have all types of different kinds of units to be able to field on the tabletop. And of course, our unit types are going to have to go into formations. And we haven't made a base formation class yet, though, so we'll have to make that in a future video. And again, this video is all about just building a basic architecture, kind of organizing our thoughts from a 10,000 foot view. You know, we want to make sure that everything it makes sense, you know. Before we start getting real heavy into hacking on our game logic, we want a nice, sane foundation to build on. Something that's going to be easily extensible and maintainable without spaghetti code and the shitty architecture, to be quite honest. Now, I have talked about architecture a bit and a bit about the onion architecture, but you can see here that, you know, we're only going to try to make as many namespaces as we actually need. You know, we don't want to, again, we don't want to go crazy with our architecture here. We want things to be simple. We don't want it to be over-engineered. So, like for example, the phase controller is going to be responsible for moving the gameplay through each of the phases that we listed in the previous turn phases enumeration in the core namespace. So we'll implement that logic in a future video. So the turn controller, same thing. It's going to basically, it's going to be controlling the phase controller. It's going to also take into account some other controllers, right? Basically, the turn controller is going to be one of the main components that we have here in our system. It's going to control the flow of all the phases and all the models and everything else that occurs during the turn. Alright, so we're also going to need an RNG. And our random number generator needs, they aren't that crazy, you know. We just need a reliable way to generate 6-sided dice rolls and the occasional 3-sided dice roll. So our random number generator is going to be fairly simple to implement. We're just going to need to we can use the one that's in system or whatever the appropriate namespace is. In the future, we might use like a Mersenne twister or some other kind of random number generator. But you know, we don't really need that guarantee that a Mersenne twister can give us if we use that as our pseudo random number generator. Let's go back and take a look at the editor. Basically, you can't see it on the screen, but because I have some of the windows hidden, but essentially Unity is taking a look at all the code that we've written so far and should be trying to compile it, make sure it can execute and build the game without error. You can also see that we've got some more folders in our scripts folder that we don't have representations of in the solution model developed quite yet. But that's okay, because as we start building out more and more of this code, we'll start fleshing out these namespaces with the appropriate scripts. So again, we have our base controller, our base data sheet, base engine, base model, base rule, base special rule, base unit type, base war gear, our factions and turn phases. We're going to need some other stuff like base faction, base turn phase, things that we talked about earlier that we'll add in an upcoming video. Again, we want to make our architecture as clean as possible from the beginning. Right? You don't want to find yourself 6 months down the road in your development cycle having to make some cataclysmic changes to your engine because something is too fucked up to begin with, right? So, one of the next things that we do in a future video will be to actually implement some dice rolling logic. But it's going to be really easy. Essentially, we're just going to make an RNG. We're going to make a random object. We'll instantiate a random object, and whenever we want a D6 roll, we'll just pull a random number from the range of 1 to 6. It's that simple. It doesn't have to be any more complicated than that. Again, this means we'll be able to use our system for a lot of things, from rules interpretation to an actual digital version of the game, whatever we want.